According to our tradition, I wish you a good day, a good afternoon, and a good evening. I am Mara Nicolau, High School Co-spun Program Manager, along with the Apoorva Bangalore Rava Prasad. I come from Romania and I study medicine at Lucian Blaga European University from Sibiu. My journey with spun debates started 5 years ago when I debated alongside people from all over the world. And after that wonderful experience, I wanted to get more involved in this program. So I became a volunteer and started to work on what was happening backstage. I can proudly say that I'm honored to be part of this extraordinary team. And I'm grateful because I had the opportunity to be part of this family very dear to me. And now I introduce you the heart of our family, NSS Education Director and NSS Space Policy and Universalization Debates Program Director, Frances Delutri.
Hello, everyone. It's great to see you all here. I wanted to just talk a little bit about how the spun debate program started. It was in 2017 at the National Space Society's International Space Development Conference in St. Louis, Missouri, here in the U.S. At that time, Dr. Lorna Jean Edmonds spoke to us on a concept called universalization. This is a construct that is quite interesting because it talks about universalization implying a pervasive focus not only on global issues per se, but on social, technological, economic, and cultural challenges and opportunities that extend into our solar system, our galaxy, and well beyond. And here's the catch, where cooperation supersedes conflict negotiation. The universalization goals are sustainability of humanity and our diversity. And that's exactly what we're trying to do in the spun debate program. We have students from around the world come together on different teams and then prepare with coaches to debate certain space-related topics. This year, we have 10 different countries represented in the high school debate program. Very excited about that. Never had that many countries represented in one year. So without further ado, Mar, I'll take it back to you.
Thank you, Frances. Now, some rules for this forum. So during this forum, I will kindly ask you to have your cameras off and mics muted. Also, all attendees, please put your first name in your panel. I can see that most of you have already done that, so that's great. Debaters and coaches, please enter your country and questions into the chat for the speaker to address during the session transitions or when he asks for questions. Even though you've submitted them on email, I will kindly ask you to write them again so that we have everything there and we do not want to miss any of your questions. I will read the questions offered, so please make sure that they are in the chat from the beginning. And also, if you get any questions on the way, just write them there and I will read them. Now, let's welcome our speaker for today, Mr. Jim Plaxco. Jim Plaxco is president of the Chicago Society for Space Studies, serves as the economics subject matter expert for the National Space Society's Space Ambassadors Program, and is a NASA JPL Solar System Ambassador. He would be talking to both sides of the 2024 high school resolutions with relevant references or argument framing. He often weighs cost, risk, and benefit in space projects and will add his expertise to our resolution. Space development would best be performed by autonomous AI and robotic systems. Mr. Plaxco has previously served as the National Space Society's Director of Information Systems, as an NSS Vice President, and was twice elected to the NSS Board of Directors. Other relevant nonprofit experiences include serving as president of the Northern Illinois Space Advocacy, vice president of the Planetary Studies Foundation, as manager of the Enterprise in Space Orbiter Design Contest, and as a judge in a variety of space art contests sponsored by NASA, IAA, and NSS. In addition to his space and economics activities, Mr. Plaxco is a digital artist, creative coder, software engineer, public speaker, and writer. Mr. Plaxco, the floor is yours.
Well, thank you very much, Mara. Good morning, everyone. It's great to be here. And I've tried to structure my presentation a little bit differently for this group. I want it to be a little bit less formal than a typical presentation. And I would encourage you to ask your questions in the chat as I am going through each of my few slides. And then at the end of each slide, I will, address the questions and we'll make it as much as possible more of an interactive discussion. So I think I'll just go ahead and share my screen right now. Let me see if this is going to work. You should be seeing a thoughts on the resolution screen. Can someone confirm that for me?
Yes, we can see it.
Yay, wonderful. So this is really the way I decided to approach this was as if, I was on a debate team. And so I'll give you my perspectives, and this is why I think your questions are so important, so we can explore different aspects of this topic, being space development would best be performed by autonomous AI and robotic systems. Or we could shortcut that to say space development best performed by machines. So I would say that those are your three key concepts when it comes to thinking about how you want to approach this topic. So my outline is I'm going to give you a few definitions and some rationale. Talk a little bit about framing the argument. Talk about technological considerations, some financial considerations, some of the pro reasoning, some of the con reasoning, and possible areas of contention between the pro and the con positions. And I think it's important to start out by defining space settlement because that is a superset of space development. And for many people, the reason for space development is ultimately space settlement. So if we can, at least I define space settlement as being the extension of our system of life and interactions on a permanent basis to places outside of the Earth, whether they're on the moon, Mars, or let's say in an L5 space colony. And the importance here is on the word permanent, so that people would lead the entirety of their lives in a non-Terran environment. And we're also talking about a significant population, not a temporarily manned base, let's say like ISS. ISS is certainly not an example of space settlement. So another key consideration, and this is where space development really comes in, is that there is an expectation that these colonies collectively will be entirely self-sufficient. Although the colonies individually may not be entirely self-sufficient, they do have a level of development so that they could be self-sufficient for some period of time if there was some serious interruption in their supply chain. And so let me quickly check the chat and see if there's anything here. Okay. So nothing specifically about space settlement. So if you talk to people and ask them why space settlement is important, you'll get back a lot of different reasons from people. Perhaps the most all-encompassing reason is to spread life throughout the solar system to ensure humanity's long-term survival. Others have argued that it's an insurance policy for the human race in the event of some sort of global catastrophe here on Earth. This could be in the form of, let's say, a major asteroid impact, like the Chicxulub impact from 65 million years ago, that was responsible or is seen as being responsible for the demise of the dinosaurs. Others have argued that we would pursue, of course, a space settlement in order to gain access to the mineral and energy resources of the solar system. If you look back to the 60s, there was a couple of good books that expressed a great deal of concern about humanity's ability to meet the resource needs of an ever-growing population. And the most prominent of these books was a report titled "The Limits to Growth," which is something you might want to look into as a part of your research. And tied in with gaining access to the resources of the solar system, another popular argument was to relieve population pressures here on Earth. Another early prediction that was made based on a optimistic projection of technological progress. And this was a prediction made by Gerard O'Neill back in the mid-70s. And that was that if we continued at this pace that he imagined, he felt that by 2050, the entire population growth of the Earth would be offset by people immigrating from the Earth to the various space colonies. And another argument that's been made is to relieve industrial pressures on Earth. Obviously, the whole process of mining and manufacturing does have an impact. In fact, you could argue that everything we do has some type of impact on our planetary system. Moving operations into space was seen as a way of increasing our access to resources while at the same time alleviating some of the negative impacts of the creation of those resources. And lastly, some people have argued that its space settlement is an excellent way for us to broaden our horizons because it presents us with a vast array of new challenges, the opportunity to create new types of societies that will be faced with novel situations. And the more we learn from those types of experiences, the better off we are all going to be in the long run. And now for space development. This is also a term that its definition depends on who you're asking. So you will get different responses from different people depending on how they are looking at the problem space. So the definition I've given here is my own. So the development of technologies, infrastructure, and capabilities that make it possible for humanity to conduct operations in space. And you'll note that in that statement, I'm not saying anything about whether these operations are based on human activity or machine activity. So just as geographic localities on Earth need physical infrastructure to support economic development projects, be it electrical distribution, a transportation network, resource storage. If we're going to have localities in space conducting economic development activities, they too are going to need to have infrastructure in place so that they can conduct those activities. And this is true whether it's in free space or on the surface of the Earth. Can I center myself to the middle of my screen? I think my camera shifted. There we go. So, and this gets us to a point that I think is going to be relevant for the debate. And that it has to do with the rationale for space development. So for some people, the rationale is to have access to new energy resources. The leading candidate in this category is solar power satellites, which is the harvesting of solar energy in space and in the transmission of that energy to the surface of the Earth for its distribution into the grid. The other energy resource that people discuss a lot is lunar helium-3, helium-3 being found on the moon and having been identified as an excellent fuel source for fusion reactors. Others have argued that we would want to have access to new mineral resources via asteroid mining and lunar mining. There was something of a craze about this back circa 2017 with a number of very optimistic projections being made as to where we would be by today. And these arguments have tended to focus on platinum metal groups, which would be most important, especially if we migrate into having a more of a hydrogen-oriented economy. And fortunately, there is a fair amount of debate as to the economic practicality of these types of operations. So that is something, if you're going to be touching on mining space resources for use here on Earth, you might want to look into some of the cost analysis as well as our current consumption of, let's say, metals, for example. How much is newly mined, how much is recycled, and how demand has been growing over the years. Most uniquely, though, we're talking about access to the zero-G gravity environment, which is what you've got with ISS. And using that environment for specialized manufacturing processes to basically make materials, pharmaceuticals that we simply cannot physically make here on Earth because gravity interferes with that process. So there is a strong case to be made. So this is something I would suggest you look into as a part of your debate research. Another rationale for space development has been to push the boundaries of science forward. And that comes in two forms. One form is coming up with systems that can work in this environment that is very different than our own environment, where you are missing Earth's 1G gravity factor, you're operating in a vacuum, and you have extreme temperature swings based on whether or not you're in sunlight or shadow. And now that will tend to push engineering forward more so than science. But the access you have to this new environment means you'll be able to carry out types of science that you can't do here on the surface of the Earth. And a classic example of that would be in the area of, let's say, astronomical observations. There are some popular graphics out there that show that when you're looking at incoming radiation, and by radiation, I'm talking about electromagnetic radiation. And so that would be visible light waves, radio waves, infrared waves, all are forms of radiation. There are certain windows in our atmosphere that allow those specific types of radiation to reach the surface of the Earth, but a lot of that is blocked out. And the only way to see a lot of that radiation is to get your eyes above the Earth's atmosphere. Another rationale for space development is to be able to develop and deploy planetary defense systems so that we will have some protection here on Earth from the threat of asteroid and comet impacts. I already mentioned the Chicxulub impact of 65 million years ago. If you'd like to see a meteorite crater firsthand, you can go on Google Maps, go to Arizona and look for a meteor crater there. So this is a real threat. It's a threat that's difficult to quantify. It could be that we will all live out our lives with absolutely nothing happening, but on the other hand, a long period comet could make an appearance and strike the Earth. Another rationale that's been given is to develop space as a means of supporting space settlement, that being the expansion of human activities into space. So you have a larger goal when you're talking about space development. You're just not using it as a place from which to develop, harness new resources, but you're building the foundation for a future home for humanity. And lastly, another rationale for space development is to accelerate innovation and technology spin-offs. We've had several advances in this area where attempting to get things to work in the zero-G and gravity environment has led to new ways of doing things here on Earth to try and mimic that environment. And I think one example that you should be able to find a fair amount of resource on is what's known as bioreactors. So now this, I think, is an area where the two teams, whether you're a pro or a con, you may want to come to some different definitions as to what the purpose of space development is. Are we pursuing space development for its own sake as a next step forward in our technological progress? Or are we pursuing space development to explicitly create a factory or factories in space that can make products for return to Earth and consumption here on Earth? Or are we pursuing space settlement specifically to serve as an enabler for ultimately space settlement? Or are we pursuing a hybrid or approach where we're doing this space development to benefit Earth's population by having access to new resources and new manufacturing processes, as well as laying the foundation to enable space settlement and ultimately the creation of a richer, more diverse ecosystem? So in this, I just wanted to give you some examples of the types of research that we're already doing in low Earth orbit aboard the International Space Station, which is arguably very limited in terms of its capabilities. It really is set up primarily for research and not manufacturing, although there has been some small scale testing of creating things in space, most famously doing 3D printing aboard space station to see if that technology would work there. And there's also discussion of doing 3D printing outside of the space station's environment. And by that, I mean, if you're in the space station, you're at room temperature in the presence of an atmosphere. The only thing that's different from here on Earth is gravity. But would a 3D printer operate outside of the space station in the vacuum of space where you have these huge temperature swings depending on whether or not you're in the sun or shadow? So some of these investigations are things you might want to consider in terms of arguing for or against a robotic development. For example, is a robotic approach equally beneficial or equally applicable to all these areas of research? Or are there areas of research that would fundamentally benefit from having a human being in the loop? Another component here that I just want to touch on is something called technology readiness levels. And this has to do with risk. Basically, we have technologies, you've heard the term, a cutting edge technology. It's new, It's unproven, and because of that, it's going to be very costly. Versus we have mature technologies. We have a really good understanding of how the technology works, and we can implement it very cheaply in a short period of time with a high degree of confidence that it's going to work. So that would be at a technology readiness level, let's say of 9, which is at the top of our thermometer. Those are technologies that we are most confident in. And we don't have to think about them. But you get down to that TRL 1 or 2 or 3, those technologies, we think they're going to work. We've got there, maybe they work on paper, but we've never built it. Back in the late 70s, there were serious studies done of with respect to implementing a system of solar power satellites to provide clean energy for Earth. One of the criticisms of the system, which is why it was never developed, what had to do with the technology readiness level of the various technologies that would be required to implement the system. So the further towards the bottom of this thermometer you go, the further away you get from that TRL 9, the greater the cost and the greater the risk. And also the greater the time commitment you're going to have to make, because you're going to have to test those technologies and validate them. So this is something to be considered when you're talking about space development. Is the thing that you are arguing for a very high technology risk undertaking or a very low technology risk undertaking? So anytime you're investigating any particular technology as a part of your research, you should ask yourself, where is this technology on this scale? Because risk, time, money are all tied in together, and they all work to impact either positively or negatively your probability of success or failure. Now, when it comes to framing the argument, and I'm sure you guys know all about framing of arguments, I looked at it and I thought, okay, where's the wiggle room in this resolution? Parts of it are pretty cut and dried, but space development, well, what is space development? What's its purpose? Why is it important? I think it's going to be important for both the pro and con team to come to an understanding within their team as to what it is they're talking about when they're addressing the issue of space development. You're going to need to clearly define what you're talking about for your audience, who is primarily going to be your judges. And the other thing for you to consider is, if you were told to switch sides from pro to con, from con to pro, would you define space development in the same way? And how would that definition differ from the pro side of this argument to the con side of this argument? The other component of the resolution, excuse me, that I found had wiggle room was the phrase best be performed. What does that mean? I'm not sure what best performed is in this case. Are we talking about how much it costs to do something, how effectively it uses resources? Does best mean minimizing the amount of risk involved? Does best mean having the greatest productive capacity? Does best mean being able to achieve your objective in the shortest time frame? So again, I think the pro and con teams may have very different concepts of best performed. And you're going to have to make the case for why your definition of best performed, I think, is the appropriate definition. Technological considerations, this whole debate topic is really largely about technology. And the state of the relevant technologies is going to be central to whether or not any project you're undertaking is practical. So the factors you have to consider with respect to whatever it is you're doing is the degree of risk, the cost, the amount of time it takes to implement, how maintainable is your system, how durable is your system. Well, for example, what's the mean time between failure, which is the MTBF? All of these are going to impact the feasibility of a project. So if in the course of your debate, you're going to be citing some specific case in support of your position, I would think you would want to consider these components and identify whether there are strengths or weaknesses for your position. And obviously, TRL9, those are the mature, well-understood technologies. They're going to minimize the risk, the cost, the time factors. But if you're relying on an unproven technology, you're looking at accepting more risk. It's understood that it will be more costly and will require more time to develop and deploy. And I thought I would make a list of relevant technologies for you to consider. Obviously, central to anything we do is our access to energy. How are you going to create and store and distribute the energy we need for whatever it is we're doing? If we're talking about doing things in space, propellant is going to be crucial. We can't ship everything up from the Earth. Water, we typically, when we're talking about space, we're thinking of water in terms of life support. But, mining is a very water intensive industry. And if you want to know a little bit more about that, you might want to look into the challenge of lithium mining for the production of these electric batteries for automobiles. Take a look at how much water is required for lithium mining. So you've also got the issues of waste heat, thermal management of your systems. Your transportation capacity, that's okay. By capacity, I mean, how much can you move at a time? How reliable is that system? How many times does your vehicle crash or explode? The cost of your system and your frequency, which is how often are you able to travel from point A to point B? Are you measuring things in terms of hours, days, weeks, months? An example of that is the Space Shuttle program. The original concept was that, yeah, the Space Shuttle will fly 50 times a year. it never achieved it. I think the best year it ever had, it had like 11 flights in the best year, I think, and that might be an overstatement. It tended to be more like 4 or so flights. If we look at the Artemis program today, which is the NASA program to return people to the moon, they're talking about using the Space Launch System for the missions. The problem is with the cost of that system and the capabilities associated with supporting it, they're talking about only being able to launch one time a year, which I would argue is something that is not sustainable. That is a dramatically too low of a flight rate. Life support systems, that's also a technology that's in its infancy. The most sophisticated we've got to date has been aboard ISS. We're also going to need a much greater amount of in-space communications capability as the number of objects we have in space grows. We have to greatly improve our ability to carry out what's termed space traffic management. A little bit more on the arcane side is these micro electromechanical systems, and this has to do with the mechanisms that are going to be in our machines that are doing things in space. We need to improve their TRL levels, which means also, lowering their cost, improving their reliability and durability. It's also seen as crucial that we develop space nuclear power systems. And this is something that we've really kind of let slide over the years with the whole general anti-nuclear thing, extending to people not wanting to do research on nuclear power systems for use in space. We'll need to figure out how to harden up significantly the electronics. Obviously, if we have people in space, we are going to have computers in space. And if you're arguing in favor of robotics and AI, again, you've got computers in space. So this is a technology for which both the pro and con have the same challenge. And that is, how do we protect our machines from radiation that can cause them to, make mistakes. And then lastly, there's all the technologies associated with food, growing your food. So I just refer to it as creation, processing, storage, handling, and disposal. And I could say here, which is important again, recycling, because we want to minimize the supply chain to Earth, which means we have to maximize recycling. The financial considerations are crucial. As I indicated previously, with respect to the demise of the solar power satellite proposal, it was the cost that did it in. And that cost took several different forms. One of the costs was because of the immature technology readiness levels, which add time and expense to your budget. There was also the amount of time it was going to require to construct the system and bring it online. So you had very significant development costs. And then lastly, it was felt that from an operational perspective, that the cost of the electricity so generated would not be cost competitive with existing ground-based sources of electrical generation. So if you're arguing for any project in space, you've got to understand your total capital requirements, the payback period, which you can think of as being minimal time to product. You know, how quickly can you get up and running and producing the good or service that you hope to use to recoup your capital costs. And of course, this all ties in with how much risk. A high risk project means that you've got a pretty good chance of failure. Your project could fail and you lose everything. And lastly, there's something referred to as your return on investment. If you require capital to start your business and you go to a venture capitalist, a bank, whoever, they're going to want to know, one, how much risk is involved in your project. Two, how quickly you're going to start being productive with your project. In other words, how quickly you're going to be able to make money and then start paying us back. And three, how much do you expect to make? If you come up with a project and you say it's going to cost me $1 million and I expect to make $500,000, no one is going to give you money because you'll never be able to pay back the $1 million. And that is simply a bad use of resources. So as I say here, capital is a limited resource and there's a significant competition for its use. There are a lot of projects out there that would like to be funded. And for all of these projects, a decision has to be made. Is this the best use for these scarce resources? And that's really at the core of what economics is all about. It's how do we allocate resources when the demand for those resources is greater than their availability. So I did a presentation last year, the impact of artificial intelligence and robotics on space settlement. And I was very careful in terms of structuring or framing my argument in that presentation. I used my framing very deliberately to say what I was specifically going after. So I presented my case to say, I'm assuming the only reason we want to pursue space development is to get energy from space from solar power satellites, deploy a planetary defense system, mine the asteroids and the moon, do zero-G research and zero-G manufacturing, period. That's it. That's all we care about. And so my argument was that we could more economically efficiently and with a greater probability of success achieve those goals if we relied exclusively on machines to do the work. So, and for me, what made this line of reasoning work was by very narrowly defining the purpose of space development in terms of what we wanted to achieve from space development. So if we're sitting around and we're on the pro side of this argument, what might we be thinking about in terms of our investigation? Well, technology readiness levels are we relying on mature technologies to make our case, or TRL1 technologies, high risk, high question of success? What about our total capital requirements? Are we proposing something that's financially reasonable or realistic? How risky is what it is that we are proposing? Is the position we're taking minimizing risk, as opposed to the other side of the debate? Are we taking into account the immediacy of the need for benefits here on Earth? And lastly, if you think of this as a system, as an independent system, are we creating a simple system or a complex system? So, and I parted from my standard here, I've actually included this quote about automation. So I think we all understand that automation has been a fundamental driver of productivity growth, and productivity growth is a fundamental driver of improvements in our standard of living. Now, if you're on the con team, so you're not arguing for something, you're arguing about why the other side is wrong. But maybe you're not arguing about why the other side is wrong. Perhaps you want to argue about why the other side's position is insufficient, that maybe it's overlooking a greater level of benefits that can be achieved via having a human presence as a part of that system. And for me, I would say, okay, if we would want to broadly define what space development means, because the broader that definition, the more value that people bring to that development. So, for example, let's consider space settlement as being the key benefit of space development, because space development puts in place the infrastructure that we're going to need. So that's one line of reasoning that you can pursue. You can also argue that the integration of people and machines will actually lead to a greater rate of innovation and technological development if you left it to just machines alone, which consequently would support the ability to create a greater range of products and benefits for the human system than a system that's relying solely on machinery to achieve some end. So if I was on the con side of the argument, some of the considerations that I would say we would have to investigate and argue over a definition of the nature of the long-term benefits that we want to achieve. We want to argue that the benefits of a larger, more diverse space ecosystem are significantly larger than they would be with a smaller, less diverse space system. We might want to talk about the challenges associated with fully automated systems, and I would encourage you to look up dark factories and analogize with what we see going on, let's say in the Earth's mining industry, which is moving towards roboticization of mining. Dark factories is all about removing the human from the manufacturing process. So you can look and see how well or poorly these systems are currently faring, because there are many situations in existence today that are reasonably good analogies for the resolution that is being debated. It's just that the resolution is transferring the setting from here on the earth to the alien environment of space. So again, you want to look at, how crucial is the role of having people in the loop to the success of the system, and how you'll get a larger range of benefits with a system in which people are working alongside machines than in a system that is limited to what machines can do on their own. So possible areas of contention. So if I'm a judge and I'm looking at this, what are the topical areas over which a pro team and a con team might differ in their outlook? I would say first has to do with the definition of space development. I can see the two teams taking different approaches to this. I can also see the two teams taking different approaches with respect to defining what is meant by best performing. And of course, the two teams can argue about total cost of the operations. But, if you take that in isolation, you get an unbalanced, or you may have an unbalanced viewpoint, because it could be that the lower cost operation, let's say on a dollar for dollar basis, yields proportionately less benefit. So perhaps system A takes only $10 to build, and your annual ROI is $11. So you're making, let's say, $1 a year. The other team may have a system that costs $30 to build, but their annual return on investment is $50. So clearly, even though they're more expensive, their returns are proportionately greater, which then becomes the justification for that added cost. Another area of possible contention has to do with system complexity. Are we talking about implementing a relatively simple system or a relatively complex system? And what is the difference in the degree of risk associated with the two systems? What is the difference in the degree of productive capacity of the two systems? Again, recall what I just previously said about cost. It's about proportionality of your cost inputs versus your benefit outputs. If the complex system gives you proportionately larger benefits, it's actually better. Timeframes and time factors is another point of contention. One side could be arguing for payoff in a very short time frame. The other side could argue for payoff in a significantly longer time frame. Risk components and degrees of risk. This is something that both sides must take into consideration. But again, as with timeframes, you have to think in terms of proportionality. We accept greater risk if there is a greater reward in store for us. And I think a case needs to be made whether or not cost, complexity, time, risk are justified in terms of the rewards that you will receive or that humanity will receive at the end of the road. And perhaps most challenging is going to be the quantifiability of benefits. I'm going to say that you're going to be largely on your own on this one, because this really is tied in with predicting where we would be in the future. I've got reports going back some years as to where various developments in space would be today. And as a rule, a lot of them are way off base. They were overly optimistic. So I would focus on the, let's say, the degree of uncertainty surrounding whatever it is you're trying to quantify. And lastly, degree of autonomous capabilities. And that is, again, all about proportionality. Are fully autonomous systems as capable of integrated systems? And that concludes my formal presentation, and it's time for some Q&A. So I'm going to scroll back to the top here. There was a question from Team Psyche. How can we relate the concept of universalization to the topic of AI, robotic systems, and space development? That has to do with the fact that I'm not sure how well you can relate that, because the development of robotics and AI is basically being led by independent companies who are pursuing development paths.
Jim,
Many
could
have
I
tried.
speak to that?
Pardon me?
Could I speak to that?
Sure.
I think exactly as Jim is saying, we are talking about activities on the Earth affecting what's out in space. And so the universalization happens on the Earth between companies that are working together with collaborations, etc. Even within those companies, what are we doing to encourage those companies to have diversity within their companies in approaching solutions to having space development? Is there a way to do more than regulate that? Certainly, we're seeing in the U.S. a social responsibility movement, and so we're seeing a lot of talk about equity and diversity within companies. But we're talking about companies working around the world, sometimes in symphony with one another, sometimes individually. So that is how the universalization is starts right here on Earth to then be manifested in space. I think that's what I wanted to say on that, Jim. If you have other comments or you want to move to another question.
Well, for me, it's, I hate to say it, but that's kind of irrelevant to what's going on with companies. I think it's not so much universalization, it's our policymaker attitudes towards the upside versus downside of AI developments and whether fear or optimism will dominate when it comes to policy.
I think you're absolutely right. I think it's important not to debate the issue here, just to give the how that universalization will enter into the picture, because that's what we're about here.
So what implications would AI-driven space exploration have for international space law and governance? I would say that you could replace AI-driven with human-driven. So I would say whether it's a robot or it's a human that is in space, the space law principles are going to be largely the same with respect to governance, which is my definition in this context is governance is about how do you treat people who are living and working in space. And I would say that becomes a trickier issue that will be more tightly controlled by the policy makers, because a robot, an AI-based robot, it's a machine. It's a car, it's a truck, it's a tractor. It's just another machine. And the governance is really about liability for damage your machine causes. So if we are pursuing, robotics, we're still going to have the issue of, okay, if I land my robot on an asteroid or the moon and start mining, is that legal? What are the rights of the company that landed that machine and is doing something? So, depending on the specifics of the action, I would say that robotics would have a less disruptive impact, or maybe not less disruptive, but a less urgent to address impact than if you had people in that same environment doing exactly the same thing as the robot. Because obviously, a machine is a machine. It is not a human being. So our attitudes are obviously quite different on that. And hopefully that kind of answers your question. If it doesn't, feel free to ask a follow-up question in the chat. From Team Juno, to what extent can a team argue that a combination of humans and machines would be best rather than one or the other? Now, you kind of cut to the heart of the argument, I think, with that question. And unfortunately, that comes down to that last point I made about quantifiability, as well as the previous points about proportionality. If your emphasis is on, we want to do it fast, cheap, and with minimal risk, then you're going to argue for the robots only. Now, that's probably also going to limit potentially your long-term benefits. So if you're minimizing your investment, if you're minimizing your risk, you're probably also going to be minimizing your returns. But if you're willing to accept a greater degree of risk, a greater degree of cost, a greater degree of development time, then my thinking is that in the long run, you are going to have proportionally a greater degree of benefits. So you might want to argue about the short-term considerations versus long-term considerations. So again, that goes back to the time frame that you may want to establish. But remember, if I'm arguing for a short time frame, the other team can come back and say, yeah, but if you took just that little bit longer time frame, look at how much more you would achieve in benefits. So I would say in addressing this issue, you have to take into consideration, all the pieces that are in your puzzle. And that has to do, for example, we wanted to have a return to the moon. There was a vision for space exploration. It was going to return humans to the moon. In the end, it was canceled because it was seen as requiring too much resource and taking too long to reach the objective. So it could be that if we had just talked about sending a robot to the moon, maybe that project would have succeeded. It would have gone forward because it could be done in a shorter time frame with less risk and less capital required. And so thinking about that aspect of robotic versus human and robotic development is something that you are going to have to take into consideration, not just in constructing a pro or con argument, but in rebutting arguments that may be made by the other team, showing the relative strengths and weaknesses of the two arguments. So Team Jonah, that was a good question. Team Capstone, will the implementation of an autonomous robotic system imply that all countries will benefit from all the discoveries made? Or do you believe that if we were to implement this idea, each space agency will have their own autonomous AI and robotic system? I would say, if you think about it, I mean, we don't have one car manufacturer, we have competition. And it's the competition between car manufacturers that makes for better cars. Because they're competing on features, capabilities, and price. And so if you go with one system, that implies a monopoly-oriented philosophy where this is the way we're going to do it, period. And you're basically shutting down alternative investigations. So to me, that is an anti-diversity approach because with the diversity we need is diversity of thought, diversity of approaches to how to solve a problem. Some space agencies may try and fail with their approach, but we do learn something in the process. I'm not aware of the exact quote because I've seen so many different versions of it, but think about Edison and the light bulb and all the times he tried to make a light bulb and all the times he failed. But he learned from all of those failures. And so that's the great thing about having multiple approaches is team one can look at team two and say, oh, that's not working for them. So let's look at our own design and see what our weaknesses are compared to their strengths and weaknesses. The thing that's thorny implied that all countries will benefit from all discoveries made. Knowledge does flow fairly freely, except when it's associated with intellectual property rights. Because if I do a lot of work to develop something, I did that work in order to reap the potential benefits of that work, which is why most every country has strong copyright laws to protect the creators of inventions from the theft of their inventions. So I wouldn't say that all countries will benefit. I would say will humanity benefit? And I would say sure. Humanity has benefited from the American investment in the internet. Everybody now has the internet, right? So I would use that same analogy transposed into the space settlement. And I guess a really good one here is if one country develops the capability of preventing an asteroid from impacting the Earth, everybody on Earth benefits from that system because the Earth is a single integrated ecosystem. What impacts negatively one country ultimately creates ripples, across our ecosystem. Is the continuous development of AI sustainable for the environment? Now, I'm going to guess that what you're talking about here is the energy requirements. Just as Bitcoin mining consumes a lot of energy, which I kind of frown on because I personally don't see the value there. But I do see the value of the energy consumed in the development of these large language models, which are behind what makes generative AI possible. So is it sustainable? I would say yes, it is, because again, it comes down to a question of cost and benefit. I think the benefits that we will gain from generative AI and whatever its ancestors are greater than the costs. These projects wouldn't be pursued if the groups pursuing them didn't see a benefit that was greater than the costs. Now, the challenge for us is this. There is no technology that we've ever developed for good reasons hasn't been turned to bad uses. And so the question is, how, to what extent will AI be used for bad reasons instead of the reasons for which it was intended to be used? But I would not, if I was on a con team, I don't think I would try to approach the issue by attacking AI in that way. I would approach it more along the lines of, I'll tell you what, a term you can look up is generative AI hallucinations. Although I can see why the term hallucinations is being used, but technically it's not a hallucination. I would say it's just the fact that these models don't understand. You may ask ChatGPT a question. It does not understand your question. It does not understand the answer it has given you. It is simply taking a pattern of numbers and running them through a model and re-encoding them into a different pattern of numbers. And that's where these hallucinations come in. So what you could do is voice your concerns over the ability of the AI and the robots to, function entirely independently of human interaction or without immediate human oversight. And I think that got me through all the questions that I saw in the chat. And Francis, you just indicated to me I've got 3 minutes left. So does anyone want to ask any other questions at this time?
If I may, Jim, I
Yeah.
want to thank you. This was amazing. This is the second year that I've had the pleasure of hearing you with the Mentor Forum, and this was really an excellent event. I hope that the notes that you have here will be made available to the teams. I do want to kind of give a message to the debaters that are here. So what you saw was a wonderful, positive presentation, right, of space development and whether or not it would be best performed. And so all these, even the con cases you heard there, we're still assuming that the space development will occur, right? The question is whether or not it will be AI or will be humans. This is a fully autonomous question. So keep that in mind that, this is the National Space Society. So we're working under the assumption that certainly it will happen, and it will. I just was at Cape Canaveral yesterday. I got badged for a project there, and the Blue Origin building is incredibly massive at the complex there. And so it is happening, right? And so it's how do we best manage this for goals of universalization, that sort of thing. But the negative cases probably should take into account that this is occurring, right?
Thank you so much. Thank you so much, Mr. Plaxco. Thank you so much, Coach Maple, for this summary. Now, I think we can turn on our cameras so we can see each other. All of you, please turn on your cameras. And also, Coach Maple asked, the recording and Mr. Plaxco's notes will be available on Space Edge Academy, and also an email will be sent to you in a few hours after the recording is downloaded. Also, you all will be getting an invitation by email from NSS to be a panelist at the University spUN Mentor Space Forum webinar. You may find it helpful in your debate preparation, as this one was incredibly helpful for you as well. The panelists will not be involved in the presentation, but may ask questions during the forum. The University Mentor Forum will take place next Saturday, March 16th at 8:30 a.m. Central Daylight Saving Time. Pay attention to the time zone. The 2024 University spUN resolution will be the international community must establish regulations for space-based solar power to mitigate potential hazards. And Mr. John Mankins is the world-renowned authority on space-based solar power and the mentor for this forum. So we are looking forward to having you there, having as many as you were today. So we thank you all again for being here. Thank you again, Mr. Jim Plaxco. This was really, really helpful. I think everyone can agree. I personally have never seen such a helpful mentor session before. I wish I was a debater right now, really. So thank you all for being here, and thank you for this wonderful experience.
Thank you, everyone, and good luck with the spun debates.